Students, this is my fourth lecture on this chapter, that is equilibrium of coplanar forces. In the first three lectures, we had covered the theoretical concepts of this chapter, that is equilibrium of coplanar forces. We also covered the problems of type 1, that is equilibrium of concurrent force system. We covered the problems of equilibrium of parallel force system, that is type 2. We also covered 5 problems on equilibrium of general force system. Now I'm continuing in this lecture, that is the concluding lecture for this topic. We will discuss around 12-13 more problems on this chapter. Very much likely that you will have some problem in the examination from this lecture. Now, equilibrium of general force system. What are the equilibrium conditions for general force system? Sigma fx equal to 0, sigma fy is equal to 0, and sigma ma is equal to 0 with usual notations what we have been using. Now, I start with sixth problem of this type 3. Find the support reaction at B and load P for the beam shown in the figure if the reaction at support A is 0. You are given with the beam for this support reaction at A is 0. What does it mean? At A, you have the hinge support. That means the two hinge reactions will be 0. So we will draw the free body diagram of the beam and I'll show two reactions exerted by the hinge, that is HA and VA. Horizontal reaction at A, vertical reaction, but both will be equated to 0. Both will be put 0. Then 10 kilonewton and 20 kilonewton meter are put as it is, external loads. P as it is. Now you have to come to this triangular loading. This triangular loading. This triangular loading is acting over a length of 3 meter. Its intensity is 0 at D, at its 24 kilonewton per meter at D. Arrows are downward, so equivalent point load will be downward. What is area of triangle? Half into 3 into 24. What is that? Is 36 kilonewton. Where will it act? The length over which this triangular loading was acting is 3. So from the right side where it has the height, it will be 3 by 3, that is 1 meter. It is 1. So your free body diagram is ready. Now in this HA0, VA0, you have to find VB and you have to find P. So we start with moment equilibrium condition about P, right? Why not about A? There is no advantage if you take moment equilibrium condition about A because HA are already 0. So we have taken moment equilibrium condition about B. When I take it about B, that means I'm keeping my pen or pencil at B and I'm considering that body is free to rotate about B. We start with P on the right side will give clockwise moment about B, P into 1 clockwise. Then 20 kilonewton meter is clockwise. We have taken it left side. Now on right side, we take anti-clockwise. What are the anti-clockwise moments? 36 into 1, that is anti-clockwise moment. This 10 into 4, that is anti-clockwise. So clockwise moments have been written on right side and anti-clockwise moments about B have been written on the right side. You get the value of P as 56 kilonewton. Now you need to write sigma Fy is equal to 0. Sigma Fy is equal to 0 means what? Upward forces are equated to downward forces. What are the upward forces on the beam? VB is up. That's it. There is no other upward force. Down is what? VB is equal to 10 plus 36 plus P. So VB is 10 plus 36 plus P. P is already known to you. Just substitute the value of P. You get the VB as 102 kilo. It came positive. That means assume direction of the roller reaction is correct. All right. Now we move to the next sum, that is problem number 7. The question is find reactions at A. At A, you have what kind of the support, student? First time you are coming across in the chapter, fixed support. A is fixed support and it's like it is a cantilever beam. It's a cantilever beam. Cantilever means what? The beam which is fixed at one end, free at other end. So this beam is fixed at A, where fixed support will exert 3 reactions and it is free at the other end. There is no other support. So we need to draw the free body diagram of this. You can see that this is fixed support at A. 3 reactions will be exerted, HA, VA, and MA. Direction of these 3 actions are arbitrarily assumed. After that, you have 2 kilonewton, shown it as it is. Sorry. And after that, at 2 meter, you have 10 kilonewton load, have shown it as it is. Then CD is subjected to UDL of 5 kilonewton per meter. Replace it with equivalent point load. 5 into 6 is 30 kilonewton, which will act at the center of the length CD. 5 into 6, 30, 3 meter from each side, from C and D. Then 50 kilonewton meter is external movement. We have shown it as it is. You have 30 kilonewton force over here, which is making 20 degree with the horizontal. So we resolve it exactly at the same point F, 30 cos 20 and 30 sin 20. अभी और क्या बच गया? अभी ये triangular load बच गया. ये triangular load में arrows are upward, so equivalent point load will be upward. Its intensity is 0 at left hand and 6 at right hand. It is acting over a length of 3 meters. What is area of triangle? Half into 3 into 6. It comes out to be 9 kilonewton, which acts 3 by 3, 1 meter from F. So all this has been shown on the free body diagram. Now you will write sigma Fx equal to 0. Looking at this diagram, HA towards right is HA equal to towards left, that is 30 cos 20. You get the value of HA. Then you write sigma Fy is equal to 0. Sigma Fy is equal to 0 means upward forces will be equated to downward force. What are the upward forces? BA plus 9, that is upward, equal to 10 plus 30 sin 20 is downward. You get the value of BA. Then we take sigma MA. Sigma MA means what? Algebraic sum of the moment of all forces about A is 0. When you take moment about A, HAVA will go off, but mind it, this MA will not go off. MA is moment reaction at A. MA is what is? Moment reaction at A. All right. So when we write sigma MA will remain anti-clockwise moment, and I'm writing anti-clockwise moment on left side. So even this 9 will also give you anti-clockwise. The 9 is at what distance? 15 meter from A. So 9 into 15 is anti-clockwise moment that we have taken on the left side. Now we come to the clockwise moments, which will be there on the right side. So 10 into 2 clockwise, 30 into 8 clockwise, 50 is clockwise as it is, and 30 sin 20 is at what distance? 16. So this gets you the value of MA, which comes out to be 339.17 kilonewton meter. It came positive. That means my assumed direction of MA, that is anti-clockwise, is correct. So this way, all the three reactions are correct. Then we move to the next sum, that is problem number 8. Again, on identical concepts only we are taking many problems because the type is very important. Problem number 8, find support reactions of the beam loaded as shown in the figure. You are given with a beam in which one part is horizontal, another part CD is vertical. It's a one piece. So we have to draw the free body diagram of the entire beam as it is. So this is what we have drawn it over here. Here, this beam is supported by roller at A. So there will be one reaction exerted by the roller. Roller is resting on horizontal plane. Reaction will be vertical. That's what I have marked it in free body. At B, we have the hinge. At B, we have the hinge. So two reactions will be exerted by the hinge. So I have taken VB upward, HB towards right. 10 kilonewton meter is external moment has been shown at B as is. After that, come to 20 kilonewton at D. We will be replacing the resolving it at D only. 20 cos 40 adjacent will be to the left. 20 sin 40 will be upward. Done. This 10 kilonewton will be shown as it is at 1.5 meter left of B. Then we come to this triangular load. This triangular load is acting over the length of 6 meter. Its intensity at A is 4. So what is area of triangle? Half into 6 into 4. Half into 6 into 4, that is 12 kilonewton. Where does it act? 6B by 3 from A. 6 by 3, 2 meter, that has been. My free body diagram is ready to apply clean conditions. We have started with sigma Fx equal to 0. Sigma Fx equal to 0, HB is to the right equal to 20 cos 40, that is to the left. So HB is equal to 20 cos 40, you get the value of HB. It came positive, that means assumed direction is correct. Then we have written sigma Fy is equal to 0, upward is equal to downward. VA plus VB, these are upward. Downward also plus 20 sin 40 is also upward. VA plus VB plus 20 sin 40 is equal to 12 plus 10. You get one equation, VA plus VB is 9.14. Then we take moment about B. Why I decided to apply moment about B? So that two unknowns will go off. HB and VB will go off and VA will be arrived at. All right. Now start with it. Sigma MB. So HB, VB will go off. First is moment 10 is clockwise, so that will be listed. Then VA into 6, that is clockwise. All right, that's it. On the right hand side, we are taking anti-clockwise. This 10 will give you anti-clockwise. 10 into 1.5 is anti-clockwise. Even this 12 will also give anti-clockwise moment. 12 is at what distance? 4. How you arrive at 4? 1.5 plus 2.5. That is 4 anti-clockwise. Even this 20 cos 40 will give you anti-clockwise. And this 20 cos 40 is to the left above P. So assume it against the moment center. 20 cos 40 into 2, that will also give you anti-clockwise movement. What about 20 sin 40 is upward on the right side of B. So you will assume it against the moment center B, upward 20 sin 40 into 2, that will also give you anti-clockwise. This gets you the value of VA, which comes out to be positive, that is plus 18.23. Plus means assume direction of VA is correct, 18.23 kN upward. Now substitute the value of VA in equation number 1. When you substitute, you get the value of VB is minus 9.09. What does it indicate? That means VB, assume direction of VB, that is upward, is wrong. It needs reversal. So that means VB is not upward, it is downward. So we have shown it 9.09 kN downward. No need to make any correction in the free body diagram, because in free body diagram we have shown the assumed direction of unknowns. So VB is 9.09 kN down. Hope all this is understood to everybody. Now we move to the next problem, that is problem number 9. I read the problem. A bar of 3 meter length and negligible weight rests in horizontal position on two smooth inclined planes as shown in the figure. Determine the distance x at which the load Q is equal to 150 Newton should be placed from point B to keep the bar horizontal. See, bar is already horizontal. That means under the action of these two forces of 250 Newton, under the action of this 250 Newton and Q 150 Newton, bar is still in equilibrium. Now students, we should remember it from the concepts of free body diagram that smooth planes exert normal reaction. Smooth plane exerts normal reaction, and that towards the body. So now we have to draw free body diagram of this beam. We have drawn the beam of length 3 meter. I have shown 250 Newton at 0.5 meter from A. I have shown 150 Newton from distance x from B. Here, can you see that you have a plane, smooth plane, which is making 30 degrees horizontal. So reaction normal to the plane will make 30 degree with vertical. RA will make 30 degrees vertical. So that is, now you can resolve it exactly at the point A only, RA cos 30 and RA sin 30. On this side, you have a plane which is making 50 degree with horizontal. So reaction RB will be towards the beam at 50 degree with vertical. RB and is 50. So RB cos 50 and RB sin 50. This way, my free body diagram is ready. Again, students, as a precautionary note, I'm bringing into your notice that in general force system, you should resolve the force exactly at the point where it is acting. Right? Like if you are in concurrent force system, you can resolve the force anywhere because you don't take moment. But in general force system, force has to be resolved exactly at the point where it is acting. So now my free body diagram is ready in all respect. Now there are 3 unknowns on it, RA, RB, and X. Actually, if you look at the problem, he's not asking you all the 3 unknowns. He is asking you to find only X. So you can cut short the steps if you feel like, or if you have the think that some step can be curtailed to find value of X. Anyway, now we start with sigma fx equal to 0. RA sin 30 to the right is equal to RB sin 50. Sigma Fy is equal to 0. Upward forces are equated to downward forces. RA cos 30 plus RB cos 50 is equal to 250 plus 150, that is 400. You got second equation. If you solve equation number 1 and 2, you get RA, that is 311.14, and RB as 203.08. Done. RA and RB are arrived at. You want to find value of X. So you should take moment about B. We should take moment about B. If I take moment about B, all forces acting at B will give 0 moment. RB sin 50 and RB cos 50. Even RA sin 30 will also give 0 moment. All right. Now we take it RA cos 30. RA cos 30 into 3 will give you clockwise moment about B. That's it. This 150 into X anti-clockwise about B, and 250 into 2.5 anti-clockwise about B. This is what we have written. Substitute the value of RA, that is 311.4 Newton, into it, and you get the value of X as 1.22 meter. All right. In fact, he asked the value of X, but we have found the value of RA as well as RB. All right. Doesn't matter. So this is indirectly he was asking value of X, but we got RA and RB as well. All right. We move to the next sum. That is question number 10. Let's read it. A uniform beam AB hinged at A is kept horizontal by supporting and settling a 100 Newton weight by using a string tied at B and passing over a smooth pulley at C. First of all, we should understand then if I'm saying uniform beam, that means its weight is going to act at the center of the length. One part. Second point which should be noted while reading this sum, he says that there is a string which is passing over the smooth pulley at C. It is passing over the smooth pulley at C means what? Tension the string on the two sides will be same. Tension in the string on the two sides will be equal. We had discussed this when I was discussing free body diagram concepts. I had discussed that if there is a string or wire or cable taken around frictionless or smoothly, tension in the rope on two sides will be equal. Keeping all this in mind, we are ready to draw the free body diagram of the beam. In this step, the problems, you should draw free body diagram of the beam if you are looking for reaction at A and tension in the cable. If you are looking for reactions at C, then you should draw FBD of pulley. In this problem, he is asking reaction at A as well as reaction at C. That means I'll have to, for finding the reaction at A, I have to take FBD of B. I have to take what? FBD of the beam. So let's start with free body diagram of the beam. Now, at A, there is a hinge support. So we have taken two reactions, H and A. Directions are as well. Here, there is a triangular loading. What is area of triangle? Half into 3 into 15. Half into 3 into 15, 22.5 Newton, which will be acting 3 by 3, 1 meter from A. Then at 4 meter away, you have 100 Newton, which is acting downward. I've shown downward. This is attached to a string, which is taken around frictionless pulley. So tension the string will be same. So I've taken this tension as T. Of course, it will be taken away from the beam when you are drawing FBD of the beam. So tension will be shown away from the beam. Come to B. At B, you have, it is again supported by the same string. So again, you'll be replacing the string with tension T away from B. All right. Now, you need to resolve this tension. It is acting at angle theta. This angle theta, if you write it over there, looking at the given diagram, tan theta can be arrived. If I write theta at this point, tan theta is going to be 3 by 6. That gets you the value of theta. Here you have resolved T cos theta and theta. Adjacent is cos, other is sine. So your free body diagram is ready. Now you take moment about A. When you take moment about A, what will go off? That means you'll keep a pen or pencil at A, and what forces will give zero moment? HA will give 0, VA will give 0. Even T cos theta will also give you 0 moment. All right, now we start clockwise moments on one side, anti-clockwise on other side. First, I'm taking clockwise moment. 22.5 into 1 will give clockwise moment about A. 100 into 4 will give clockwise movement about A. That's it. T into 4 will give anti-clockwise movement about A. T sine theta into 10 will give you anti-clockwise movement about A. This gets you the value of T. This gets you the value of T. Then we write sigma Fx equal to 0. What is that? HA is equal to T cos theta. That gets you HA. Sigma Fy is equal to 0. Upward forces are equated to downward forces. So VA plus T sine theta plus T is equal to 22.5 plus 100. That gets you the value of. All right, we got reactions at A now. We also got tension in the string also. If he had asked you the reactions at A and tension, then problem is over. You don't need to take other part, but he is asking reaction at C. Mind it. Now we'll have to draw FBD of the pulley. FBD of the pulley, when you draw it, you'll have to show tension T away from here. You have to show tension T. Dimension of the pulley are not given. So this becomes example of concurrent force system. This angle is theta. So we resolved it anywhere on the tail side, T cos and T sine. Now at the center of the pulley, it is given a big dot is shown over there. All right. And this is like a rod which is there. All right. It's a suspended, this pulley is suspended using a rod also, which is, I mean, you can say that this pulley is hinged at the center to the pulley. All right. Now, so at the center C of the pulley, you will take two reactions because center of the pulley will not move in X and Y direction. So it is like, hinge. So HC and VC. Now, since it is example of concurrent force system, we'll apply sigma Fx and sigma Fy is equal to 0. Sigma Fx is equal to 0 gives you HC is equal to T cos theta. That gets you value of. Sigma Fy is equal to 0. VC is equal to T plus T sine theta. That gets you the value of VC. All right. So again, I repeat that FBD of the pulley is example of concurrent force system since dimensions of the pulley are not given. If dimensions were given, it becomes example of general force system. we move to the next sum. I read next sum. Problem number 11. A crane pivoted at end B is supported by a guide at A. Determine the reaction produced at A and B by vertical load W is equal to 5 kilonewton applied at C. Students, at B, can you see that there is slight hole sort of is there in which the crane bottom point or so support is pivoted. That means if with this kind of support, by your simple observation, you can understand that lower part or lower end of the crane cannot move in X and Y direction. The crane lower point is supported, lower end is supported or pivoted in such a way that it cannot move in X and Y direction. So we can understand that support B will act as a hinge. So we have shown two reactions, HB and BB at A. And here this crane is supported by a string or a cable. This is by guide at A. Guide at A means there is like a cable is there. So this guide at A, there will be tension in the cable because when you apply 5 kilonewton load on the crane downward, crane tends to bend towards right. So there will be stretch, there will be extension in this cable. So we will show tension over there. All right. Then we write sigma Fy is equal to 0, Vb is equal to 5 kilonewton. Sigma Mb is equal to 0 gives you 5 into 2.4 clockwise and T into 1.8 anti-clockwise. That gets you the value of T. Then sigma Fx is equal to 0, Hb is equal to T. That is the value of HB. Now, see, a question will always should come to your mind. When should we find resultant reaction of hinge or when we should not find? So it is simply based on English. If they, by reading the problem, you conclude that single reaction is required at hinge, so you have to find resultant reaction. And by reading the problem, if you conclude that he is asking reactions at hinge, so then it means you can leave the answer in component form. Like in this problem, if you read it, he said determine reaction produced at A. Reaction means what? Single reaction. So that means resultant reaction at B is required. So what I have done it now, I have drawn another diagram showing HB and VB. HB is 6.67 kilonewton to the right, VB is 5 kilonewton upward. You can draw and show them on a separate diagram, then RB is arrived at. RB is resultant reaction of hinge B. RB will be equal to square root of 5 square and 6.6 square, that is 8.3. Alpha is equal to 10 alpha is 5 upon 6.7, or alpha is 10 inverse of 5.6.67, that is 36.87. So again, I repeat that in this chapter, resultant reaction of the hinge is required only when you feel that after the reading the problem that single reaction is required. If single reaction is required, it is essential for us to find the resultant reaction at hinge. Okay, we'll move to the next sum. Question number 12, I'm taking now. Now, in question number 12, a man raises a 12 kg joist of length 4 meters. By pulling the rope, find the tension in the rope and reaction at A. Students, in this joist means like a beam or a bar. Can you see that in the floor, there is a small drop in the floor. There is a small drop in the floor and your joist is being supported by junction of horizontal and vertical plane. Can you see that? The joist is being supported by junction of horizontal and vertical plane at A. All right. So that means, and it is being pulled by the rope by a person as shown in the figure. You will understand that it is supported at A in such a way that it cannot move in X direction, it cannot move in Y direction. So in short, we can say that support at A will act as a hinge. Support at A will act as a hinge. All right. Now, so we will take two reactions at A when we draw FBD of the joist, that is HA and B. Because the reason also is given, there will be two reactions at A as shown. Since joist is supported at A by horizontal as well. This is supported by vertical plane, so horizontal reaction, horizontal plane, vertical reaction. So it is not a hinge, but it acts like a hinge since it is exerting two support reactions. So HA is the reaction exerted by the smooth vertical plane, BA is the reaction exerted by the smooth horizontal plane. Then weight of the joist is acting at the center of the length, that is 12 into 9.81, 117.7. Come to B point. At B, there is a tension in the rope. It is at 25 degree with the joist. Then this angle is 45. As this angle total will be 45, 45. Again, I repeat, this angle is 45. So over there, alternate angle, what this bar joist will make with horizontal is 45. So 45 minus 25 is, this is 20. Can you see that? Here total this alternate angle will be 45, total angle here with horizontal angle. What the joist is making the horizontal at B is 45. This as alternate angle, 45, 25 is given, 45 minus 25 is 20. So T cos and T sin. We have resolved the tension. Now this is 4, this is 45. 4 cos 45, 4 sin 45. Half length is 2, so this is 2 cos 45. Now we take moment about A. When I take moment about A, HAVA will go off. 117.72 into 2 cos 45 is clockwise. T sin 20 into 4 cos 45 is clockwise. T cos 20 is to the left. Perpendicular distance is 4 sin 45 is anti-clockwise. Clockwise moments have been listed on left side. Anti-clockwise moment has been listed on right side. You get the value of T, that is 98.4. Then we write sigma Fx equal to 0, HA is equal to T cos 20. You get HA. Sigma Fy is equal to 0. Upward is forces are equal to downward. Upward is VA is equal to 117.72 plus T sin 20. So substitute the value of T into that, you get VA. As understand that HA and VA are not the reactions exerted by the hinge. HA and VA are the reactions exerted by the smooth planes. So there is no question that HA and VA can come out to be negative. HA and VA have to be normal to the plane and will be towards the body. Anyway, but he's asking reaction at A. Reaction at A means resultant reaction at A. So we will draw another diagram where we'll show HA and VA to correct direction. HA is 92.54 to the right and VA is 151.4 Newton upward. Then RA is shown and at angle alpha. RA is equal to HA square plus VA square root of that. You get 1777.44. Tan alpha is 151.4 upon 92.54. That gets to the. All right. I have written a note here when to find resultant reaction when single reaction is required. Then you need to club HA and VA into resultant reaction I. All right. We read question number 13. A boom means like a beam only. AB is supported as shown in figure by a cable runs from C over a smooth pulley. Smooth pulley means what? Tension, the string on the two sides will be same. Compute the tension T in the cable and reaction at A. Neglect the weight of the boom and size of the. This time he is not asking any reactions at the support of the pulley. So we will be taking only FBD of the beam or the. What will take? FBD of the beam or the. All right. Now we draw free body diagram. There will be two reactions at A, HA and VA, as there is a hinge support at A. 890 Newton is vertically down, we have shown. 445 is vertically down, shown. Then at point C, you have tension T. This tension T is inclined, its slope is defined by a right angle triangle where 2, 1 is defined. So which we take it, tan alpha is 2 by 1. Tan alpha is 2 by 1, you get alpha. This is slight error is there. This is alpha value, not all right. So once you get alpha, you can get cos alpha and sin alpha also. So we have resolved it T over here, T cos and T sin. All right. Rest all we have done little geometry here. What we have done it, this is 0.6. So this distance in this right angle triangle 0.6 cos theta. In this bigger right angle triangle, this hypotenuse is 1.2 meters. So this is 1.2 cos theta, 1.2 sin theta. In this bigger right angle triangle, length AB is 1.8 meter. So this is 1.8 cos theta. All right. We start with sigma MB. Theta value is also required. How do you get theta? This is also defined by 3, 4, 5 right angle triangle. I have written here theta. So here we have shown 4, 3 was given. I wrote this hypotenuse of 5. So here tan theta is 4 by 3. Cos theta is 3 by base upon hypotenuse, 3 by 5, 0.6. Sin theta is 4 by 5, that is 0.8. So all these angles, cos, sin value have been determined. Now you have to find the value, you have to apply moment equilibrium condition. What you have to apply? Moment equilibrium condition. When we apply moment equilibrium condition about A, let's see that. When I apply sigma MA HA VA will go off 890 into 0.6 cos theta clockwise. 445 into 1.8 cos theta clockwise. T cos alpha into 1.2 sin theta anti-clockwise. T sin alpha into 1.2 cos theta is also anti-clockwise. You get the value of T. Once you get the value of T, you can apply sigma Fx is equal to 0. HA is equal to T cos alpha. You get H. Sigma Fi is equal to 0. VA plus T sin alpha is equal to 890 plus 445. That gets you the value of T. Again, students, if you read the problem, he is asking reaction at A. Reaction at A means what? Resultant reaction is required. Resultant reaction means what will I do again, students? I'll show HA and VA to correct direction. HA is 333.75 Newton to the right. VA is 667.5 Newton. Then RA is marked an angle. We have taken the resultant reaction. RA is making angle beta with horizontal. Why beta I have taken? Because theta and alpha are the notations which are already used in the problem. So RA is equal to HA square plus VA square, square root of that comes 746.3. Then 10 beta will be equal to 667.5 on 333.75. By mistake, it is written alpha, but actually it is not alpha. Hope you can understand. It is actually beta. Hope everybody understands it. So we got the angle, what the resultant reaction makes with the horizontal. Let's move to the next sum. Well, students, this is a little lengthy problem, but very important. Many times such problems are asked in the university examination. As you can see that this problem has been asked in the Mumbai University examination 3 times, in May 2018, December 2013, and even June 2002. Right? So I have listed the years in which this problem was asked in ME examination. In my opinion, this problem covers the entire concepts of equilibrium. In my opinion, this problem covers the entire concepts of equilibrium. If you can solve this sum, that means you know the all concepts of equilibrium, because it involves concurrent force system, it involves general force system, it will involve fundamentals of equilibrium. The problem also involves the geometrical part also. Let's read the sum. Question number 14. A cylinder weighing 1000 Newton and 1.5 meter diameter is supported by a beam AB of length 6 meter and weight 400 Newton. As shown, neglecting friction at the surface of contact of the cylinder, determine number 1, wall reaction at D, hinge reaction at support A, that means I need resultant reaction at A, tension in the cable BC. Now, this is the diagram given to us. You have a beam which is hinged at A and it is supported by a cable at B, which is connected to the wall at C. This angle is given to as 60 degrees. This beam is also supporting a cylinder of weight 1000 Newton and diameter 1.5 meter. Cylinder is in contact with the beam at P and it is in contact with the wall at D. That means at D also, at P also, there will be normal reactions. Students, here we can draw free body diagram of the beam. You can draw FBD of cylinder. FBD of the beam will be example of general force system. FBD of the cylinder will be example of concurrent force system. If you take beam and cylinder together, then also it will be example of general force system. Students, if we need to draw here free body diagram of the beam and cylinder separately. Reason for that is, initially if you look at it, there are 4 unknowns are there in the problem. One is wall reaction at D, hinge reaction at A, that means HA and VA, and tension the cable. If 4 unknowns are there, and if you take beam and cylinder together, then you'll have only 3 equilibrium conditions. So you cannot get 4 unknowns. So that's why we have decided to take the FBD of the cylinder and beam separately, so that FBD of the beam will be general force system, which will get you 3 equilibrium condition, and FBD of the cylinder will be example of concurrent force system, which will get you 2 equilibrium condition. Total 5 equilibrium conditions will be available if you separate the beam and cylinder, and total 5 unknowns will also appear on the FBDs. What will be the 5 unknowns? HA, VA, RD, RP. RP is a common reaction between cylinder and the beam, and tension in the cable at B. Tension in the cable at B. Now, we need to draw the given diagram as it is also. Why? Because we have to find distance AP. To find distance AP, little geometry has to be done. What way geometry will be done? From the center of the cylinder, draw perpendiculars on this side and this side. Now, you'll find that triangle OAP and triangle OAD are congruent. What you'll understand? The triangle OAP and OAD are congruent. How they are congruent? This is radius, OD and OP are radius, right? This angle 90, this angle is 90, and this side is common. This angle is 45. So this is 45 divided by 2 is 22.5, 22. Then in triangle OAP, we understood this angle is 22.5. So tan 22.5 in triangle OAP is going to be tan 22.5 is OP upon AP. OP is radius, that is 0.75 meter upon AP. AP comes out to 1.811. So this way the distance AP is arrived at. All right. Now we first draw FBD of cylinder. If I draw FBD of cylinder, weight will be vertically down. Cylinder is supported by smooth vertical wall. So reaction RD will be horizontal towards the cylinder. I have marked it. This beam is making 45 degree with horizontal. Common reaction RP will make 45 degree with vertical. So this way 45. Here this is a fit case to apply Lami's theorem. RD upon sine 135, RP upon sine 90, and 1000 upon sine 135. Now this is what has been marked over there. Okay, using Lami's theorem, you get RD and RP. Now we draw free body diagram of beam AB now. When I draw free body diagram of the beam AB, what do you see that it is beam was hinged at A, so two reactions HA and BA are shown. 400 Newton is the weight of the beam. Length of the beam is 6 meters, so it is taken at 3 meters. Over here, T is taken, tension T or a string or cable T is making 60 degree with vertical. All right. How do you understand it was making 60 degree? All right. It is from the given diagram. Now you can see that here. So this is you can see that here this cable is making 60 degree with the vertical at C. Cable is making 60 degree with the vertical at C. All right. So this is what we have used it, and AP length has been obtained at 1.811 meter. Okay, and beam is hinged at A. So this is weight 400 Newton at 3 meter. This is RP 1414.21. That's what we got it here. This beam is making 45 degree horizontal. Reaction RP will make 45 degree vertical. We resolved it. This is RP cos 45, 1414 cos 45, and 1414.21 sin 45. Both the components come out to be 1000, 1000. T is 60 degree vertical, T cos and T sin. This way, and in this right angle triangle, we have written this distance which will be needed when we take moment about A, T cos 45. In bigger right angle triangle, length is 6 meters, 6 cos and 6 sin. We will be taking moment about A. When you take moment about A, HAVA will go off. Moment of RP can be taken directly. 1414.21 into 1.811. Why we can take this moment directly? Because this force 1414.21, that is RP, is perpendicular. Since it is perpendicular to AP, right? So we can take its moment directly, or you can take moment of its two components. 400 into 3 cos 45 is clockwise. Then T sin 60 into 6 sin 45 is anti-clockwise. T cos 60 will assume it against the moment center A. T cos 60 upward into 6 cos 45 is also anti-clockwise. This way the value of T is arrived. Then we write sigma Fx equal to 0. HA plus 1000 is equal to T sin 60. That gets you the value of HA. HA comes negative. Negative is what? Assumed direction was wrong. We assumed it towards right. That means it is to the left. Sigma Fy is equal to 0. Upward forces are equated to downward. VA is upward plus T cos 60 upward. Downward is 1000 plus 400. That gets to the value of VA. VA comes out to be upward. Then he's asking resultant reaction at A. So we draw a diagram. Show VA vertically up, HA to the left. Then RA is equal to HA square plus VA square root of it. It comes out to be 1209.75. And alpha is equal to 10 inverse of 1105.86 upon 490.5. That gets you the value of alpha. So in this problem, we have done two free body diagrams. Free body diagram cylinder was example of concurrent force system. FBD, the beam, is example of general force system. So the problem covers the concept of two types of the problems. Very important type of the sum. Let's move to the next sum. All right. Problem number 15 being taken. Find support reactions A, B, and C for the rigid link DEF supported by the cylinders at D and F. The link is loaded by a single force of 20 kilonewton as shown in the figure. Neglect friction and self-weight to the link and cylinder. Take diameter of the cylinders as 200 mm and D and EF as 3. Now you can see that there is a rigid link DEF. That means it is one piece. It is hinged at F and D. All right. It is supported by the smooth planes. Here it is supported by a smooth vertical plane at A, smooth horizontal plane at B, and smooth inclined plane at C. In this problem, he is not asking, there are only three unknowns. What are the three unknowns? Reactions at A, B, and C. So it is advisable in this problem to take the FBD of the entire system as 1 unit. What is the advantage of if you take FBD of the entire system as 1 unit? Because on the FBD, only three unknowns will appear. What are the three unknowns? RA, RB, and RC. So there is no sense in separating the cylinders and the rigid link. So you can take, if all the things, if rigid link and cylinders are not separated, there will not be any common reaction which will come into consideration. So we take rigid link and cylinder together as 1 unit, so that there will be only three reactions exerted by the three smooth planes at A, B, and C. So we have drawn the diagram over here, FBD. We have taken rigid link and cylinder as 1 unit. Here, this is a smooth vertical plane, so reaction RA will be towards the body. I have shown it. Here you have the smooth horizontal plane, reaction normal will be vertically upward R. This 20 should be resolved, 20 cos 30 adjacent and 20 sin 30 to the left. Here, this plane is making 45 degrees horizontal, reaction normal to it will make 45 degrees vertical, so RC cos and RC sin. Here, this length D is 0.3 meter. So you form a right angle triangle here, 0.3 cos 45, you take this 45. So 0.3 cos and 0.3 sin. Now we can apply moment about D. Why we decided to apply moment about D? Because two unknowns RA and RB will go off. Again, I repeat, if we take moment about D, there are three unknowns on FBD, RA, RB, and RC. And if I take moment about D, RA and RB will go off and RC will be arrived at. So we take moment about D. RA and RB will go off. 20 cos 30 into 0.3 sin 45 clockwise on clockwise, and 20 sin 30 into 0.3 sin 0.3 cos 45 anti-clockwise. RC cos 45 is upward, perpendicular distance is 0.3 plus 0.3 sin 45 anti-clockwise. RC sin 45 is to the left into 0.3 cos 45 is anti-clockwise. That gets you the value of RC. Once you get the value of RC, you write sigma fx RA is equal to RC sin 45 plus 20 sin 30. You get R. Sigma Fy is equal to 0. RB plus RC cos 45 is equal to 20 cos 30. That gets you the value of R. Reactions RA, RB, and RC are towards the body, because since these are the reactions exerted by the smooth planes. So as a direction of RA, RB, and RC has to be like that only. It cannot be negative. All right. Now we will discuss a small concept of internal hinge. Internal hinge concept is also very important part of equilibrium or very important part of statics. See, hinge, external or internal, will exert two reactions. That is first. We should understand that hinge means whether it is internal hinge and external hinge. So far, the hinges what we had come across, they were mounted on the permanent object and they exert two reactions when the body is detached from external hinge. Internal hinge is something what is suspended in the air. It connects the two parts in such a way that rotation of both the parts is allowed, but movement in X and Y direction is restricted. So I read it. When two members are connected such that connection allows rotation between them, rotation is permitted and it acts like a hinge, then while it likes a hinge, it does not allow the parts to move in X and Y direction. Such a connection is called as internal hinge or pin connection. You can see that we have shown it here a scissor, where the two parts, when you are using the scissor, the two parts of the scissor are connected by a pin or by internal hinge, so that the rotation of the two parts will be allowed but the linear movement of the two parts will not be allowed in two mutually perpendicular directions. When we are solving the problems in mechanics, your internal hinge will be shown to you like this. If it is parts are shown in the thickness, two parts are overlapping each other, and then a big dot is marked. So that shows that the two parts are connected by internal hinge. Here, if it is a line diagram, big dot is marked, that is also indicative of internal hinge. Now, internal hinge also exerts two mutually perpendicular reactions, which will come into consideration only when the two parts are separated. Internal hinge reactions are equal and opposite on the two parts. Most important thing we should understand that internal hinge reactions will come into consideration only when the parts are separated. And the internal hinge reactions on the two parts will be equal and opposite. All right. Now we take one problem which is based on internal hinge, Now you can see that here problem number 16. I read it. Find the reactions of the beam shown in the figure. You have a beam which is fixed at A. All right. This beam is having internal hinge at B. All right. It is supported by a roller at C. So suppose if I draw free body diagram of this beam, entire beam as one unit. So you cannot get the solution. Why you will not get the answer or solution? Because there will be four unknowns. What are the four unknowns will be there if I take FBD of the entire beam AC as one unit? There will be three reactions exerted by the fixed support. There will be one at the roller support C. So total there will be four reactions. All right. But how many equilibrium conditions will be there? Three. Since it will be example of general force system. So we have to take a decision of separating the beam at internal hinge B. When we separate the beam at the location of internal hinge B, so you have to separate it all along with loads and all along with its reactions. So first I have drawn FBD of the beam, right hand side part BC. Why we decided to draw the right hand side part first? Because it is workable. Here there will be only three reactions, HB, BB and BC. Whereas if I draw the FBD of the left hand side part AB, so there will be five reactions initially. Five unknowns will be there. So first we solve the part which is workable, which is can be solved, that is right hand side part. So we have drawn right hand side part. So we have separated. So there will be two reactions. I have marked it at internal hinge HB and BB. I took HB to the right, BB upward. Again, mind that direction these reactions are assumed one. This 25 Newton acting at 1 meter from B right of B at 30-degree angle will be resolved. 25 cos and 25 sin. Length of this beam is 3 meter. 5 Newton per meter UDL is replaced by equivalent point load. 5 into 3 is 15 Newton. 1.5 meter from each side. Your FBD is ready. You write first sigma Fx is equal to 0. HB is equal to 25 cos 30. Sigma Fy is equal to 0. VB plus VC is equal to 25 sin 30 plus 15. You get another equation. Take moment about V. HB, VB will go off. Even 25 cos 30 will go up. 25 sin 30 into 1 clockwise. 15 into 1.5 clockwise. VC into 3 anti-clockwise. You get the value of VC. The value of VC is 11.67 positive. That means it is upward. Now substitute the value of VC into equation number 1. You get value of VB. V becomes 15.83. That is positive. That means upward. That means internal hinge reactions on this part BC have come out to be right. That means I got HB positive. That means assume direction of this is right. That is to the right. VB comes out to positive. That means upward. Now, when we go to the other part, students, we have to show this internal hinge reactions exactly opposite to what it is on this part, because they are equal and opposite. Here HB is to the right. Here you show HB to the left. Here VB is upward. You'll show here VB downward. All right. Rest all will be taken. Here A is fixed support, so we have shown three reactions, HA, VA, and MA. Directions are assumed. There is a UDL of 4 meter length on part AB, 5 into 4, that is 20 Newton, 2 meter for each side. 40 Newton meter movement is external movement, has been shown as it is. Now we are ready to solve this part. Sigma Fx equal to 0 gives you HA is equal to 21.65. That means it's positive, assume direction is correct. Sigma Fy is equal to 0 gives me VA is equal to 20 plus 15.83, so 35.83. Positive, assume direction is correct. Take moment about A. Sigma MA is equal to 0. When we take sigma MA, students, what will go off? HA will go, VA will go, even HB will also go. MA is anti-clockwise, 40 is anti-clockwise, right? For 20 into 2 clockwise, 15.83 into 4 clockwise. We have taken anti-clockwise movements on left side, clockwise movement right side. You got the on solving, you got value of MA is positive. That means assumed direction of MA is correct. So we'll now we have come to the last problem of this chapter as well as of this lecture, that is problem number 17, which is given with one internal roller. This concept also we need to understand. What is the concept of internal roller? As I explained to you, internal hinge, same the internal roller. Internal roller will exert one reaction which will be equal and opposite. Internal roller reaction comes into consideration when the two parts are separated. That is what is the difference between internal roller and external roller. Now I'm reading this problem number 17. The beam AB and CF are arranged as shown in the figure. Determine the reaction at A, C, and D due to the forces acting on the beam as shown in the figure. In this problem, there are two beams. One is AB and another is CF. They are connected by internal roller at A. This is internal roller. You can understand the internal roller is not connected to any permanent object. In fact, it is it is a supporting system between the two parts, whereas external roller is at E. Suppose I think of taking the entire structure and the two beams together as one unit, then there will be 5 unknowns. Why 5 unknowns? There will be 2 reactions at hinge A, HAVA. There will be 2 reactions at hinge C, HCVC. There will be 1 reaction at D, that is V. So total 5 unknowns, 5 reactions will be there. So you cannot solve it. So we have to separate the two FBDs. We have to draw FBD of AB and CF. We will start with free body diagram of part AB, because if you start with FBD of part CF, you will have 4 unknowns: HCVC, V, and VD. Whereas if you start with free body diagram of beam AB, you will have only 3 unknowns. So you should start from the FBD of part AB. So there will be 2 reactions at A, HAVA. 20 kilonewton is external load, we have taken it. 40 kilonewton is at 45 degree, 40 cos and 40 sine, we have resolved it. Internal roller reaction, I have taken V upward. Internal roller reaction, we have taken upward. We write sigma fx equal to 0, HA plus 40 cos 45 is 0, so HA comes minus 28. Minus is, that means assumed direction of HA was wrong. It is not to the right, it is to the left. Sigma Fy is equal to 0, VA plus V is equal to 20 plus 40 sine 45. We got another equation. Take movement about A. When you take movement about A, HAVA will go off. Even 40 cos 45 will also go off. 20 into 3 clockwise, 40 sine 45 into 4 clockwise, V into 3 anti-clockwise. That gets you the value of V as 57.71 kilonewton. Why upward? Since it is positive. Then if you substitute the value of V in equation number 1, you get value of VA as minus 9.43. Minus is indicated that reaction VA is not upward, it is downward. Now you draw FBD of part CF. At C, you will take 2 reactions. We have taken HCVC. This 20 kilonewton at 1 meter from C is at 60 degree angle, 20 cos and 20 sine. V reaction is upward on part AB, so here it will be downward, and its value is known to you, 57.7. At D, there is a roller, so roller reaction will be vertically we have zoomed it upward. This 10 kilonewton and this 10 kilonewton are external loads. They have been assumed as it is. Now we are ready to apply equilibrium conditions on this part. There are 3 unknowns on this part. What are 3 unknowns? HC, VC, and V. Sigma Fx equal to 0, HC plus 10 to the right is equal to 10 plus 20 cos 60 to the left. You get value of HC as 10. Sigma Fy is equal to 0, VC up, VD up, equal to 20 sine 60 plus 57.71. You get another equation. Take movement about C. When you take movement about C, HCVC will go off. Even 20 cos 60 will also go off. 20 sine 60 into 1 clockwise, 57.71 into 2 clockwise, VD into 3 anti-clockwise. Now you 10 kilonewton. This 10 kilonewton, assume it to the left above C, 10 into 0.5 anti-clockwise. Even 10 below lower one, this one, assume it here to the right, will also give anti-clockwise 10 into 0.5. Students, we have listed anti-clockwise moments on left side, clockwise moments on right side about C. So you get value of VD which comes positive. That means assume direction of VD upward is correct. The value of VD is substituted in second equation. You get the value of VC which comes out to be positive. That means it is assumed direction is correct. So students, total 17 problems we have discussed on type 3. right? In the colleges, they will not cover all types of the problems. They will cover only few problems, maximum 3, 4, or 5 problems, right? In my book, we have many more solved problems are given in the book. You should refer the book. If you refer the book and if you watch my video lectures, you can aim 100 on 100 in the examination. That is what I assure. All right. In case of any difficulty, you can mail to me. Mailing address is given in my book. Even my mobile number is given. Exceptionally, if you have some difficulty, you can call me up also, or you can send your difficulties, or you can fix up the time on WhatsApp also, and then I'll definitely give you. There are no charges, or this is all free service. All right. The book is available on Amazon. It is, we have arranged the free delivery, as well as there is some discount also on it. Link, Amazon link is given in the video description of this lecture. All right, book has lot many MCQs on every chapter, because you are likely to have again online examination. So there will be MCQs will be asked in your examination. So these MCQs are given in the book. All right, I have given many more solved problems given in the book. All right, so video lectures are free, not only for those people who are buying the book. Video lectures are free. You can share the QR code with your friends, so that they can also watch my free video lectures. All right, you can subscribe to my YouTube channel, so that you can continue to get the notification as and when the new videos are uploaded. All right, so with this concluding lecture, the chapter of equilibrium of coplanar forces is completed. Thank you.